Good afternoon and good evening, everyone. My name is Stephanie Caldwell, and I will be moderating today's webcast, Enterprise-Wide Connectivity, the mission-critical role reliable, standardized enterprise connectivity plays in digital transformation. This webcast will be recorded for replay purposes and be sent to you at the end of the session. Before we get started, I'd like to cover a few housekeeping items. At the end of the presentation, we will take questions from the audience. To submit a question, please use the Q&A widget at the bottom of your screen. If you feel as if your slides or videos are delayed, press Tab on your keyboard to refresh the console. Also, on the right-hand side of your screen, there are tips for the best webcast experience for your reference. Lastly, please refer to the resources widget on the bottom of your screen all the way to the right. Here you will find a link to the LNS research report, Plant Data and Connectivity, Strategic Building Blocks for Industrial Transformation. If you would like to be followed up with directly after this webcast, please use the URL widget also found on the bottom of your screen. We are thrilled to have two great speakers with us today. Tony Harris, President and CEO of eMagic, and PTC's own Steve Spiller, Senior Director of the Kepler Americas channel. We have some great content planned for our session today, and with that, I will turn it over to Steve to start us off.
All right. Thank you very much, Stephanie, for the introduction. And thank you, obviously, to the attendees that are going to spend an hour with us today to discuss enterprise industrial connectivity and how that is foundational for manufacturing and industrial companies today to achieve digital transformation. And then I'd like to give a special thanks also to Kepler's Tony Harris. Tony, thank you. For you and your company, eMagic, who is doing some incredible work out in the field that he will be sharing with us in just a little bit. To get us there, I'm going to first briefly talk about digital transformation, what it is, and how connectivity challenges are unfortunately slowing it down and hindering it from scaling across various enterprises. I'll then hand it over to Tony to provide some use case examples of projects his companies have been involved in that have achieved digital transformation by addressing enterprise connectivity head on, not just in the manufacturing space, but also in building automation. Tony will be discussing their version of a digital twin and how that helps marry the digital world and the real physical world. We'll then get to the fun, interactive part of the hour where the audience will be able to send in questions for us to address via that chat window. All right, so most presentations in this space these days, start with some basic definition of digital transformation or IIoT, Industry 4.0, or the fourth industrial revolution, whatever you want to call it. At the end of the day, all manufacturing and process companies are looking to do and have always looked to do three basic things: increase revenue, decrease operational costs, and increase asset efficiency. These are obviously not new goals for the industry, but what is the embracing and implementation of the latest, greatest technologies that are coming together to provide the means for some amazing advances in these areas. And it all starts with a business strategy, and obviously there is no one-size-fits-all or silver bullet solution. Each and every company is unique to at least some degree, and I'm sure some of us out there are maybe a little nervous about what we should be doing exactly to transform our companies and to use digital transformation. So while the focus today will be on the critical role of connectivity, how it plays in digital transformation, I did want to let the audience know that PTC, if you can see that link down there in yellow, PTC has addressed a series of digital success paths that outline everything you need to achieve value from digital transformation. Each success path provides step-by-step guides, resources, and services to help you plan and set up your digital transformation journey. There are about 10 or so chapters or considerations in this plan, and there are two in particular that I feel personally are most important. They are the plan stakeholder involvement and manage organizational change and compliance. While today's technology is pretty amazing, it won't do you any good unless you have everyone on board and throughout your company, the top floor to the shop floor. So most companies are feeling the pressure of this fourth industrial revolution and know that without digital transformation, they will fall behind the competition and be a laggard in the market. We have a couple stats and quotes here from some trusted analysts where they are reporting 90% of industrial companies are investing in digital factories to some degree, and almost 70% of companies consider digital manufacturing at the top of their operations strategy agenda. And I assume I convince anyone on this webinar that industrial companies need to capitalize on and stay current with digital technologies to remain competitive and stay in business. Digital transformation, Industry 4.0, IIoT, et cetera. We've been talking about this now for quite a few years, and there are a few lighthouse implementations, as we'd like to call them, that are proving some real value and achieving ROI. For those that have managed to achieve digital transformation at scale, they have reported double-digit KPI improvement in the targets listed here on this chart, ranging from factory output increase, who doesn't want to achieve that, to OEE improvements, quality and product cost reductions, to energy efficiency. And I mentioned this on the previous to some degree, but just to reiterate here, failure to create competitive advantage couldn't be more serious. Analysts have predicted that over half of the S&P 500 will be displaced over the next 10 years. Pretty scary. The classic example of Blockbuster and Netflix is the one I like to use, where one company failed to react and plan for the digital age, and another embraced it and ended up thriving. The message here is that the threat is real. So many companies are aware of this threat and are taking the challenge head on. According to a survey conducted by McKinsey, companies are running on average 8 projects that are related to digital transformation. Most, unfortunately, are not realizing the benefits of these initiatives. And in fact, 75% of these projects get stuck in what some call pilot purgatory and fail to scale and therefore fail to improve any real value or gain the competitive advantage that these companies were after. So why is that? Why are the majority of these companies attempting to do digital transformation pilots get stuck in purgatory and fail beyond that? As you guessed, based on the title of this webinar, or the subject of this webinar, connectivity proves to be one of the biggest challenges. We have some insight here from various analysts. First, as Kepware's traditional customer and partner base knows, most of manufacturing and industrial settings have a very complex and heterogeneous environment of processes, equipment, machines, et cetera. Life would be much simpler if within the 4 walls of a factory or out in the oil fields that all of it was provided by one vendor. Unfortunately, obviously, that is hardly ever the case. And moving on to the siloed data and ad hoc connectivity, this is speaking to the situations where each individual application that needs data from the shop floor uses its own connectivity solution. So as more and more applications arise that need connectivity, ranging from your traditional simple SCADA screens or dashboards for tracking KPIs to the cool advanced analytics to predict and prescribe what to do before a machine goes down, configuring and managing connectivity within each individual application can become quite laborious and eventually impossible to deal with changes on the floor or in the field as the process changes. Traditionally, maybe you had just a SCADA system and its historian that needed data, and you could more or less manage connectivity there. But now that there are more and more applications needing this industrial data, managing connectivity on a per application basis truly and obviously does not scale. Then lastly, even if there is connectivity throughout a environment, it may or may not be secured in a way that you'd feel comfortable allowing that data out of the network. Unfortunately, keeping that data locked in the OT network could definitely strangle any digital transformation initiatives across your enterprise. The exact metric here from IDC is that organizations said that their projects, quote, expose security concerns that must be addressed before expanding the deployment, quote. This dates back to the historical perimeter-only security stance that many industrial control system networks used, and is something that needs to be before moving forward with attempting to scale and create value with digital transformation. So as you know, there are more than a few IoT or digital transformation platforms out there, and you might be assuming that they have these challenges already figured out. Unfortunately, the connectivity tools offered by most providers are fairly anemic. They are assuming that your environments are more or less greenfield, like than brownfield, where they assume the only protocols, they assume that the machines and devices support modern protocols like MQTT or OPC UA, and these might be the only protocols supported by these platforms to ingest data. This does nothing for all the existing devices out on the shop floor that typically serve a lifespan of sometimes, over 30 years. And then moving on to SDKs, pretty much all of the platforms offer some type of SDK in various languages. This may be a little more helpful, but this is essentially the do-it-yourself or DIY option. Developing this connectivity isn't a task that should be farmed out or taken lightly. These tools will be handling your organization's most critical data, so it is very important that any connectivity software you build uses best security practices and is maintained properly for years to come. That's something to be taken seriously. And then lastly, many also have the option of a hardware gateway they provide, which can be used to convert one protocol to another, and are usually somewhat limited to an extent, and oftentimes assume that the machines are more or less somewhat similar. This also adds another device that your IT group has to network and manage, and doesn't effectively scale to meet the needs of the entire organization. So, unfortunately, the traditional connectivity tools offered by most IoT platforms simply don't support scaling to an entire enterprise IoT or Industry 4.0 project. I do believe they tell 1,000 words. So let's step through some of these connectivity challenges using this building graphic here that lead to limited data access problems when considering a typical line in a typical manufacturing factory. So as we discussed, the odds are high that you have a heterogeneous collection of machines on your manufacturing line, likely supporting different communication protocols. And then in today's world, as we've been discussing, it is likely you are using a growing number of on-premise tools to visualize, store, analyze the data, whatever. This is where we see the problem of each application having to deal with connectivity on its own and a lack of any type of data aggregation or standardization. Now, imagine this same problem existing all of the lines in your factory, many different types of machines. And if you can't get that standard connectivity, the little visibility within your plant, how could you possibly scale this across your entire organization where you want visibility across all your factories and processes? So just to summarize here, the major point is that inadequate connectivity, the lack of aggregation and standardization, creates issues for the factory that lead to not being able to quickly and effectively roll out a digital transformation deployment. But not to worry, and bear with me here, this is the only Kepware specific slide where we are announcing our TwinWorx Kepware server designed for enterprise-wide scalable connectivity. TwinWorx Kepware server otherwise known as TKS, is a repackaged version of the traditional server EX to provide standard connectivity across your entire enterprise, simplifying this challenge for your digital transformation. With TKS, you get the full unlimited access to all of Kepware's 150 plus drivers and plugins across all of your lines, all of your factories, all your geographies, all with just one license. It is now very easy to unlock the data contained in devices that have been around for years in brownfield locations. So if we go back to our multi-line, multi-factory example, hopefully it is clear that TwinWorx Kepware Server can provide a streamlined approach to connectivity across your lines, factories, and enterprise. Providing one-stop, well, I'm sorry, I admit, almost, Tony. Providing one-stop shopping for all your applications that need industrial data. Sorry, let me get on the right slide here. All right. Only having to learn, configure, and maintain one server for all of your connectivity needs is tremendously powerful and frees up your resources to work on other things like analytics analyses, process improvements, and so forth. Now that you know a bit more about the challenges with connectivity for digital transformation, turn it over to Tony to provide the additional insights into what he and his company are experiencing in the field and some of the great success stories he has led in digital transformation. Tony, the floor is yours.
Thanks, Steve. Thanks, Stephanie. Welcome, audience. My name is Tony Harris, President and CEO of eMagic. I started my journey in this area in 1986 when we formed our first software company. It was a software company concentrated on SCADA systems as well as AI, the old style AI at that time, expert systems, and a bit of neural networks. We also operated as system integrators. We worked in multiple industries globally, and that company was sold in 1998. eMagic started just after that in 1998. We're headquartered in Canada with operations in the U.S. as well as India. We started as a system integrator, and today we are a system integrator as well as an independent software vendor globally. We work with Microsoft, with Azure, and their cloud on the edge, and we are also a partner of Kepware, where we use Kepware for all our enterprise connectivity. We focus on using digital twins for centralized operations as well as other use cases. So we've been in this business for about 30 years. We've done lots of applications. Started off with the old style of SCADA and human-machine interfaces, HMIs, which today we're dealing more with industrial IoT systems. We perform things like data analytics, energy management, concentrating initially on that connectivity issue of getting that data into your system, and then being able to do things like visualizations and analytics and so on. The scope of the digital twin that we'll talk about today, too, it's not only for buildings, and it also includes facilities, factories, as well as industry. So we'll be talking today about industrial IoT, and as I mentioned before, digital twins. We'll talk about automation of factories as well as buildings, and I will give you some examples of what we have accomplished for various applications. One of the first use cases I want to talk about is for manufacturing industry. This particular customer has about 26 factories, over 200 machines, numerous challenges for them with respect to connectivity. They had many different devices from different vendors, Siemens, Rockwell, Allen Bradley, etc., no standardization, and many different service providers working in their factories. After standardization, one of the first things that they achieved is faster implementation, faster connectivity, faster integration of getting their systems up and running. It was more predictable in terms of time, less ad hoc. And one of the biggest gains for them also was the fact that now, with their standardization, they are able to use more vendors to perform the services that they needed, because there was interoperability between what each of the vendors can do. So they achieved in this case of working with Kepware, a faster implementation time, as well as being able to expand the vendors that they worked with. Another application is at the University of Pennsylvania in Philadelphia. This is a very large application in that it encompasses centralized control for the entire university. Over 300 buildings, about 600,000 tags coming into a central control room that was staffed and is staffed 24/7 by operators. We have about 5 operators that operate the entire facility. It includes chiller plants, dorms, research buildings, everything on the campus. This university was founded in 1940, so it's been a long time operating. As you would expect, being brownfield, they had systems from all different types of vendors. In the last 5 years, when we implemented the system, there were interfaces needed for over 13 different devices of many different vintages. They had a replacement program, but because of the connectivity solutions that we use with Kepware, there wasn't a need to align their replacement program with our projects. We were able to work with what they have in place to be able to provide them this solution. So they had many different devices, many vendors, no standardization, and as I mentioned, devices of many different vintages. What we achieved by standardization and the connectivity with Kepware: 1, very fast implementation. We looked at many different options as we were approaching this particular application. Some of them did not perform the way in which we expected, and later on, if there are questions related to that, we can talk a little bit more about that. However, again, we were able to get connectivity fast, get reliable connectivity. They didn't have to take their systems out to make it newer systems for us to connect. And we secured that data integrity and data security. And this application is still up and running today. There are some other applications that I just want to expose you to. We talked about the University of Pennsylvania. We did a similar thing, again, using Kepware servers at the University of Colorado. And we're currently right now implementing a campus-wide system at Temple University with Microsoft and Kepware. And these are also centralized operations for the entire campuses. This slide, I've produced this slide so that to kind of demonstrate a facility with different use cases. However, what's central to all of these use cases is that we cannot have these if we have bad connectivity. If we have bad connectivity, it wouldn't work. If we have bad data integrity, we're toast. Couldn't work. No standards, we would have a problem. With proper data organization and standardization, we could now achieve all these use cases I show you here. In this case, we're looking at use cases. The first use cases in buildings and facilities are that of centralized operations, where we integrate data from different subsystems, such as HVAC, security, elevators, power, window shades, and so on. Once we've got that data coming into the system, we can then perform things like energy management using dashboards. In addition, doing things like fault detection and diagnosis and predictive maintenance. And then we can get to workflows inside the building, looking at how the buildings are being utilized, occupancy, asset tracking, space optimization, wayfinding, even smart bins and smart toilets, all dependent on having that data and that standardized data, and then we could move to other things like the tenant engagement and tenant experience apps. But this is a stack of different things we can do in a building, starting from centralized operations all the way to the use cases within the building. But it's all dependent on having good data connectivity, good data integrity, standards to allow us to do these kinds of integrations. I'm now going to talk a little bit about our concept of a digital twin. Again, I want you to think of this in the context of everything that we're doing with these digital twins is dependent on having good data, quality data, good connectivity, and reliability in that connectivity. So with digital twins for operations as we do, we are building a digital twin, which is a virtual representation of your physical, the built environment, like a factory floor, building, a campus, a city, or even a country in some cases. I know there's no country digitized completely as yet, but we're getting there. So it allows us to manage these assets, operate them, and we'll look at some of the use cases of the kinds of things we do with these digital twins. What we do with the digital twins initially is that we're trying to model the built world, the real world, which composes of people, spaces, and things, and the relationships between those things. So we model those people, spaces, and things in the virtual environment, in your computer servers, in the cloud, or whatever the application takes. And once we've got that model, we can then map the telemetry from the real world into our digital twin. We're then able to manipulate that digital twin using various analytics or other types of things, and we'll be able to, if we want to, do bidirectional communication and send data back into the field to actually affect things like changing set points or starting and stopping equipment and so on. So the idea is that we're modeling people, spaces, and things. We then attach telemetry, and now we've got all the data from the real world in our twin. We can make decisions, we can take actions, and we can feed that back into the field. Again, all emphasizing the idea of connectivity, because none of this can be done without that. These are some of the use cases that we apply. Visualizations, command and control. You can have dashboards with KPIs, historians, alarmings. Again, fault detection, diagnosis, and we can perform things like simulations, predictive maintenance, augmented reality, and so on. But I'm emphasizing, and I'm showing this slide, or I have this slide in my presentation, to emphasize that all of these things that you see on the right-hand side, from visualizations down to augmented and virtual reality, depend on having proper connectivity, reliable and quality data, standards, and when we are looking at different vendors or different integrators doing things like different digital twins, having a standardized protocol as well as standards for how we tag our data. From an operational standpoint, with a digital twin, you see and experience exactly what you get in the built world. You have a 3D model. You have navigation, as you would, in our case, as you would in a game. You have augmented reality, virtual reality. This slide is actually taken from an actual application where it's a chamber of a performance hall. And that model was a Rivet model that was imported into a gaming engine. Similarly, if you have a very large facility, a campus, you can pick a building, go to that building, go to the basement of that building, start a pump. The cards you see on the screen are all data that are coming in real time from the field. So the bottom line on all of this, to have the digital transformation in the case of our digital twins and centralized operations or the use cases that I showed you in a building or analysis, in all cases, we need enterprise connectivity. We need good data quality. We need data reliability. We need security. We need standardized protocols so it's not one-off. We need standardized tagging so we have interoperability of applications. So different vendors can build different applications and you can use that together. And in all these cases, we utilize Kepware to provide the connectivity that we need for successful projects. Thank you, and Stephanie, I'll turn it over to you to see if we have any questions.
Wonderful. Thank you both, Tony and Steve. As you mentioned, Tony, at this will take some questions from the audience. So I have a few here. Steve, I will start with you. This question is, does TwinWorx Kepware Server require a window operating system?
Yes. Can you hear me? I just want to make sure I got
unmuted
myself correctly. Good. Yes. So just like Kep Server EX, TwinWorx Kepware Server does require a Windows OS. I believe we had a previous webinar where we talked about a new product coming out of Kepware called TwinWorx Kepware Edge, and that is a server that can run in a Linux environment. So if anyone is interested in that, we would love to talk to you. Please reach out in the chat window or some type of survey afterwards, and we'll definitely follow up.
Perfect. Tony, this next one is for you. How do you integrate Revit models into the TwinWorx 3D rendering engine?
Okay, we take the Revit model. We then add we would strip away some of the assets that are not important from our perspective for the operations. We would add assets to that model because in many cases the Revit model is built by the architects for construction as opposed to operation. We will then add the assets that we are interested for operations, and then we import that into a gaming engine, and then we map the attributes and properties of the assets, the people, faces, and things to the field.
Awesome. This next one, Steve, I think is more directed at you, but if you have any thoughts, Tony, feel free to jump in. What would you say is the biggest hurdle or roadblock for achieving digital transformation at scale?
Yeah, so I kind of mentioned this in one of the intro slides there that, I personally believe that change management, getting everyone in the company on board, getting people involved early and not just dumping a new technology on a technician that's out there in the field, here, use this cool stuff to make your job easier. I really feel it's very important to get everyone on board early and get their input.
Awesome.
Good question.
Can I add to that,
Yeah.
Stephanie? One of the things, and I don't think that we haven't seen this there yet, but it's a laborious process just mapping the real world into your assets. If it could be BACnet or even a PLC. If there's a way in which we can automate that tagging, that would be a big win for industry. Some way of mapping what we've got in the field automatically into the virtual environment, that would be a big win. I just wanted to add that.
Thank you so much. This next question, does OPC UA or MQTT have the same quality data over Kepware?
I'm sorry, can you say that one more time?
Yeah. Does OPC UA or MQTT have the same quality data over Kepware?
Have the same quality data over Kepware, or maybe like Kepware. I mean, I'm not really sure exactly what that's asking, but Kepware. Okay, maybe the question was, Kepware for many years supported OPC DA, and then started providing OPC UA as it came on the scene, and now MQTT as it has come on the scene. So from a quality standpoint, I'm not aware of any issues we have with OPC UA over the traditional DA. Certainly, when it first came on the scene, there was work that had to be done with the standard itself and with our implementation. But with version 6 of Kepware, we made a great efforts and strides to bring that up to speed to be aligned with OPC DA.
Awesome. Hopefully that answers your question. This next one we directed a little bit more towards Tony, but as always, Steve, feel free to give your thoughts if you have any. In your experience, do digital twins ever get out of sync with physical machines? If this happens, how is equivalence established?
It will only get out of sync with the machines if depending on the frequency at which you're acquiring data. Typically, we would based on the use case and the solution, I would say, rather than the use case, based on the solution, we will tweak the rate at which data is being collected to fit that solution. So that's a big part of the system integration effort. Once you've got that right, you shouldn't have any issues of it not being in sync because you're not simulating any data. All the data that's coming into the system are real data that you're bringing at the frequency that you need it. Any data you're sending out will be at the frequency that you need it. So I think that if I understand the question correctly, the issue there is just the rate of data collection. And if you've got that right, you won't have a problem with it being out of sync.
Wonderful. Thank you, Tony. Steve, I'll throw this one your way next. Can you give me an example of not ripping and replacing to enable digital transformation?
Yes. So one of the large oil and gas companies out there that have many refineries, those refineries are run by DCS systems that have been around forever, and you really don't want to mess with those systems or you're wreak havoc on the overall process. So they ended up putting sensors, additional sensors on the existing equipment. They used a different network. They didn't use the DCS network. They used a new kind of IoT network, and they were able to pull data using Kepware and then get that data to many different applications using all these different interfaces we just talked about. OPC UA, MQTT, and I believe even like our local historian, the OPC HDA. So I always think of that as a good example where you had a system you didn't really want to touch, but instead of ripping and replacing, which would be super expensive and time consuming, they were able to add on additional sensors and kind of put a whole new network in place.
Awesome. Thanks, Steve. This next one is probably more in your wheelhouse as well. Has Kepware OPC UA limit the max number of tags?
No different than OPC DA. Yeah.
Awesome. Nice and easy for that one.
Yeah.
Does Kepware provide any data cleansing tools?
Data cleansing tools? I don't believe so. I mean, I don't really know if maybe that person could follow up with an example of a data cleansing tool or what you're ultimately looking to do. We don't contextualize the data. We are a pass through. We let you know whether or not the data is good quality, but we simply pass it through. We're an aggregator.
All right. Can you talk a little bit about Docker containerization and whether it would pose challenges for frustration?
For what again?
The question is, can you tell Docker/containerization and if it would pose challenges for front-end integration?
Oh, front-end integration would pose challenges for front-end integration. Well, I mean, the world is certainly heading towards containerization. And we mentioned that other new product from Kepware, that TwinWorx Kepware Edge, is something that the teams are currently working on. We have actually working here at Kepware where we can deploy that using container technology. But I'm not sure exactly the question of dealing with the front end integration. I mean, I think eventually we'll all get to the place, companies will be able to pick and choose exactly what technology they want to put in a container and deploy it at scale. So yeah, as we were talking about, enterprise connectivity at scale, I think that will eventually be, part of the overall solution is, that may be more of the OT and IT coming together, because that the containerization is really something the IT people are more familiar with and know how to use. But as the OT and the IT bridge gets smaller and smaller, and we all come together, I think we'll be able to get there and do some really cool things and get that standardization and ease of deployment, across your entire enterprise. Good question.
Awesome. Thanks, Steve. Got a couple more questions here. Do you do edge processing of tags? For example, multiple tags bind in near real time to have context.
I don't believe based on what the way that question was asked. Like I said, we don't contextualize the data.
Okay. Lots of Kepware specific questions. Would Kepware Edge or options work alongside and support with each other, cloud or edge-based systems from other providers? Support or integrate edge-based systems from other providers. There we go.
Yes, absolutely. Yep, it has the Edge product. Has OPC UA as a northbound interface, MQTT as a northbound interface. Between those two, that should service just about all the various applications out there that want access to that industrial data. It does also include an additional interface, and that is the TwinWorx Always On, the direct pipe into TwinWorx. But it's still open to any other application on any other IoT platform, what have you, that wants data. So what's really cool is if that edge server is truly at the edge out in the field, let's say, it could be providing data to like a local HMI. So an operator shows up at a site, he's able to see data with a local HMI, perhaps a panel, but then in parallel, that same embedded perhaps TwinWorx Kepware Edge server could be shooting that data into the cloud, into the enterprise, however you want to say it. Like I said, kind of in parallel using OPC, UA, or MQTT perhaps.
Awesome. Thank you, Steve. And I have one more question here. And Tony, I think this one's for you. And again, Steve, if you want to jump in, feel free. Legacy system versus modern systems.
Yeah, that's always an issue. It depends on a number of things. First of all, some legacy systems, there is no API. So in that case, you have to build your own. In some cases, they have API. We still have to build where there's no standard protocol that, say, Kepware offers. But I think the key thing is that regardless of if you have to build, you have to make sure that it adheres to the standard. So when it's done, it looks like the modern systems. And that way you can intermingle your old communication interfaces with the new. And when that data comes in, it looks all the same, and you can manipulate and apply it to your application or your solution in the same way.
Awesome. Thank you, Tony. Ladies and gentlemen, unfortunately, we are now out of time. As mentioned earlier, this session was recorded and will be to all registrants. I'd like to give a special thanks to Tony and Steve for joining us today, and thank you to our audience for in today's session. We hope you found today's presentation valuable and will return for future webcasts. Have a great day.
Thanks, Steph.